So first of all, thank you very much for this invitation to give this talk at Kaki. Um, I hope that you will like the topic, and I'm grateful to Kaki for this opportunity. And what I'm going to do is talk about zero. Now, zero is a very peculiar entity. It's a strange entity because it represents nothingness, and that is an idea that is not so easy to grasp. The idea that an entity that represents nothing itself is a very strange idea to many philosophical thoughts, and we will see that this problem has been a non-trivial one. Okay, it has always elicited very strong emotions. How can null have an entity identity of its own? So, as we will see, Indian culture embraced the idea of zero very easily, while Europeans hated that idea from the bottom of their heart, and they still continue to resist. Sort of internalizing the idea of zero. They use zero, of course, in sciences, you don't have a choice, but that internalization of zero that happens in India doesn't happen in Europe, even today. And we'll see why and how this happens. Acceptance of zero requires a certain kind of cultural orientation, as I will show you. Zero is natural to Eastern thoughts, especially the Vedic thoughts. It comes very naturally, and we'll see how. But in West, zero is not a natural number. So I don't know if you remember, but when you were taught natural numbers in the school, it was 1, 2, 3, 4 onwards. While in India, natural numbers would consist of 0, 1, 2, 3, 4. And we were called that whole number as zero inclusive and stuff like that. But that is actually a European derivative. In Western philosophical thought, to put it briefly, there is a supreme being who pervades the entire universe, and hence the idea that there can be emptiness or null is very unacceptable to the European thought. So, a system that was ruled by religious thinking, the idea that there could be a null was something that Europe resisted for a long time. On the other hand, Indians loved the zero. Right from the beginning, they loved zero. And I will show you how many different forms and formats of zero exist in the Indian context. The present text is about various forms of null, both some invented, some discovered, and by the humans and how they came into being. And then how different kind of cultural perspectives have made people think differently of that number. So first use of zero. So as my introduction was at the introduction we heard, Indians were not actually the first ones to use zero in arithmetic. And I will show you how it was done. So Sumerians and Babylonians have some of the earliest lookup tables for multiplications and number writing and addition, subtractions, some trading, etc. Where zero, of course, comes in, because if you do 5 plus 5, it is 1.10, and therefore zero had to be written. So that arithmetic trivial zero is something that happens. The earliest records happen in Babylonia, 3000 BC, about what 2000 years before we start worrying about it. In fact, they used the base 60 for their number system because 60 was very convenient. It was divisible by 2, 3, 4, 5, 6, of course, 9, 6 and 10. So for trading community, base 60 was easier because you could trade in a large number of fractions of this basic unit. But they thought little about it. They used blank originally, so 1 plus 1 would be 0, written as 1 and the blank next to it. But then the next blank would create problems when you were looking up tables later on, etc. So they introduced a sign for 0 that looks like this. And they started using this sign quite early. The symbol of it's worth noting that if you're writing say, a 0 as in a sentence, then you don't need this 0 representation. So 0 representation, the evidence for 0 representation is much later. Um, if you're just going to use sentences like 2003 or 10 days, may I have 10 days to 7 cows or something, you really don't need the 0. Only if you're writing the numeric values that you need 0. So the original need for a symbol for 0 actually comes from arithmetic, especially when trading is done. So this talk I'm going to give in two parts. In the first part, I'm going to talk about the very entity of zero. What is this zero and why is it worth a whole talk at Kaki? And in the second part, I'm going to talk about the culture, zero and the cultural response of various cultures and how it brings out some really interesting aspects of human thinking. So let me begin with zero as an entity. Like I said, zero is used. Babylonians in second millennium BC, Mesopotamians have 6th century BC. They have such a complicated sign for zero. Mayans in 4th century BC have a whole series of signs for zero. The earliest known Sanskrit text with zero in it actually is not in India but in Cambodia, where there is a Sanskrit text with this kind of a number for tax 605. And this was the tax you had to pay to the king for going to a particular place or something. So this was 6, this was 0, and this was 5. And this is the earliest known of zero. The text is in Sanskrit, and that is how we know that it comes from India. Ptolemy used this symbol for zero in 159 AD for astronomy and other purposes. The earliest known references to the word shunya actually comes from Pingala, 3rd century BC, and he used binary numbers. He used all kinds of interesting concepts. He was a great mathematician. Not too much of his work survives, but what survives is also interesting. And Pingala, for the first time, uses the word shunya to explicitly refer to zero. He comes up with binary systems and so on a whole bunch of ideas which are way ahead of its time. The earliest written zero as a dot comes in Bakshali manuscript 224 to 384 BC, where you have numbers 1, 2, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and then this dot represents zero. Eventually, much later, this dot actually becomes confusing, so it is turned into that oval that we use today, the one that we use today. And the earliest use of this symbol also is in India. It is in a temple in Gwalior, where again the taxes are mentioned, the amount is mentioned, and it is dated to say 876 AD. So this zero both can be traced back to India. In some sense, Babylonians use some of it, but that is a side story actually. The earliest representation of zeros actually in arithmetic was used by Babylonians, and yet Indians get credit for having discovered zero or invented zero, as your bias may be. And the reason is because the idea of shunya as a concept and zero as a number is something that is merged in India. Others are scared of doing. Others are either not careful enough or scared of doing that, and Indians are the ones who do it. And we will look at how that is done. So this worldview of India admitted nothingness culturally so much in so many different aspects that when they started doing the arithmetic or algebra of zero, they had no problem. They were not constrained by anything. There was nobody telling them that, look, it doesn't make sense to talk about nothingness. And this concept came up in a variety of environments. The invention of zero is not just algebraic, but before algebra came into being, the idea of null and zero was a very comfortable one for Indians. It is an interplay between topics of, it's a great subject of great fascination, and that's what we will look at. So let us look at Indian zero first. The idea of null is something that Indians grow up with. It has been represented, to them, it represents an amorphous, unidentified entity that could be experienced in absence. The neti kind of an idea. The null entity represented something that did not exist and had ceased to exist. There was an interesting idea that came up in a variety of contexts, and we'll look at 4 different contexts in which it comes up. We will explore these. Like I said, Pingala in his book Chanda Shastra, for the first time talks about uses the idea of 0 and 1 in terms of representing sounds, and comes up with the entire algebra of binary representation of heavy sound being the bigger one, the softer sound being the lower one. And then he constructs how exactly chants are to be constructed, not in terms of words, but in terms of this binary language about which rhythms should be used and so on. So Pingala's work includes material related to what would eventually be called as Fibonacci numbers. They were called Matrameru, and Pingala is credited with the use of light, lagu, shunya, and guru shunya in order to describe how exactly the numbering and sound fixing in Sanskrit text is done. For example, if you have ever thought about it, the way the Rigveda is recited is very, very standardized. So whether you see it on the banks of Ganges or whether you see it in a temple in South India, Even though their basic languages may be different with different kind of styles, Sanskrit text is always reproduced accurately because Sanskrit has a very high degree of standardization when it comes to the rules of grammar and rules of pronunciation. And Pingala is one of the those who sort of sets out these rules very clearly. Then, of course, Panini goes and standardizes it very heavily, and we will see that it is. So, Pingala, in principle, should be credited with the use of zero in the way that is beyond beyond simple arithmetic. It suddenly becomes a non-arithmetical entity. So let me look at the first zero. The first zero comes in the very concept of abstract zero or shunyata, emptiness. So they visualize non-existent entity from which the universe exists. So if you look at Narsee Sukta, and I'll show you to you in a minute, um, it comes as an entity. So it is not a religious concept in the sense that this is unmanifest. It is not worshipped. It is not revered. There are no temples to this great nothingness from which the entire universe arises. And it's just an abstraction of great concept. So the first idea of null is the description of the great creator from whom the world comes. And later on, of course, people have tried to give the structure of Brahma, etc. But in the original Rigvedic structure, there is nothing. And then there is this complementary idea of Purnat Purnamidam. From completeness comes completeness, and so on. So if you look at Rigved, 10th 129, it speculates on where did we come from? And the first sentence says that at first there was neither being nor being. There was neither air nor sky yet. What was wrapping where and what under what protection? It says there was no death and there was no deathlessness. And the one breathed without breath. There was by his own impulse. And then he says through the power, darkness wrapped darkness, and essentially there was nothing. And he says through the power of order, the great one brings universe to life. And then he begins with his love. In the beginning, the love arises, and from there comes the connection between beings and non-beings. And then there's a very beautiful, fascinating poem. At the end, he says, who really knows, who can presume to tell? And they say, even gods came after the emergence, so even gods can't tell. And then the poet speculates that out of which the creation has arisen, whether it held firm or not, he who surveys the highest heaven, he surely knows. And then the poets doubt, maybe even he doesn't know. This very idea that the universe has a beginning, it comes from null. And the idea before the birth of the universe is null. And out of nowhere, this energy self-generates and creates a universe is something that is there in Nasadya Sukta itself, in Rigved itself, at the beginning of these speculations. So that is the first one. The second zero, another variant of this same zero is that the fact that we are meditative people. Right from the beginning, you are told to do not just asanas of yoga, but yoga has an important aspect of meditation. And meditation essentially tells you to stop thinking. A very brain which is designed to continuously process information and collect information is now told to go beyond thought. And that is a fundamentally different practice from what is there in other places. And that meditative approach, essentially preventing thought, is another form of nulling where the brain is null. The idea of blanking out the brain is also a form of nulling. Then the early Rigvedic people we know were essentially nomadic people who traveled long distances on horses and so on. They definitely had a sophisticated language and imagery and philosophy, but they did not have a permanent residence. So they couldn't, and obviously you can't carry tons and tons of books when you're traveling. And so they, in order to preserve their creation and their thoughts, they used language in order to sort of repeat and transmit their stories. But the stories could not get into error. So the stories had to be grammatically precisely done so that pronunciation and grammar carried right through over thousands of years, essentially. And that preserved that in order to preserve their creation, they created a language which is in itself, in some sense, an artificial one, but in many ways grammatically and linguistically precise. And therefore, in using the rhythms, etc., they come out with complex rules of auditory sensitivity to ensure that this transmission precision is maintained. So you have Sanskrit. Sanskrit was the language that they developed was more difficult but precise, and that is where its value was. And the Rigveda itself is written in the form of poetry. And there's a let me look at the place. Um, so the creation itself is in the form of poetry that could be recited in the form of verses. Chanda is an important concept because you know that if you have to recite in a particular um, prose can be modified. Poetry is very difficult to modify. So they use this idea of poetry to do that. It required unprecedented precision and economy of words. And therefore, Sandhi is used. It's used only in Indian languages. The concept of Sandhi is used to allow compression of words. That permitted conservation of information but required techniques whereby two words could be merged together. And Indian set of languages are essentially the only ones that use this technique. This technique is called Abugida or alpha syllabary, where you combine letters in order, or especially combine vowels and consonants in order to compact the language. Abugida includes extensively used Brahmi scripts from South Asia. There is one Ethiopian script that uses that, and there are some Canadian Aboriginals who use similar style. But at least for Ethiopia, there seems to be some connection with Indian scripts because of the Indian trade to Horn of Africa and so on. Panini has a great role to play in defining null, and he calls it lopa, disappearance. And gives you very precise definitions of sandhi. So Panini's grammar has zero as a loss of sound, lopa, disappearance of sound. And he says disappearance of sound cannot be arbitrary. It has to be either ashravanam, you cannot hear it, ucharanam, non-pronunciation, anuplabdhi, non-availability, abhava, non-existence, and varna vinasha, loss of sound. And he defines these 5 ways in which sounds can disappear and be merged. And I'll give you an example using all these 5 things. The 5 ways of eliminating sound allows you to make that Sanskrit sloks very precise and decipherment also equally precise and therefore unique. For example, there is a very common name in Maharashtra at least, where you have Mumbaikar, Punekar, and so on. The example that I have taken is the surname of a friend of mine, and the surname is Vategaonkar. Vategaonkar essentially means Vatet Yenara Gavat Rahnara. And I'll do this in Hindi again. Vatet Yenara Gavat Rahnara, a person who is living in a village along the way, and that entire sentence is compressed into Vategaonkar. How is this done? हिंदी में like I said equivalent is रास्ते में आने वाले गांव में रहने वाले, but the term vatit and gavat are themselves sandhi. So even when I sort of take the word and break it into its components, I still am using two sandhis, vatit and gavat, and then conjunction. So to from vatit and gavat is disappears, the sound is lost. Yenara is non-availability, that word is just not put there. Rahanare is non-existent. That very concept is non-existent. And Gavat is replacement of Gavat Rahanare, which is Ashravanam. The Rahanare part is not Ashravan, is not heard, and it is replaced by Kar. And so Gavat, the Ta and the Anucharan of pronunciation replaced by O. So Gavat also becomes Gaon. That is how Vategaonkar becomes Vategaonkar. And in principle, you could call it Vategaonkar or Vategaonkar depending on what your choice is. And you could spell it either with a V or W. But you can see how much of precise definition comes in this. And just to run through the Hindi equivalent of it, and of course, if you have somebody who is Vategaonkar, it is probably easier to be on first name basis with that person rather than remember this entire exercise. In Hindi, the same thing could be done. So Vategaonkar is raste mein aane wale, gaon mein rehne wala. And Vat in Marathi is Rasta. And the conjunction is follow. May is disappeared. Raste mein disappears. Aane wale will disappear as non-anuplabdhi. Rehne wale will disappear as abhava. Gaonkar will replace gaon mein rehne wale using Kar from Marathi if you wish. And eventually May from Raste Mein will simply be not be pronounced. So Vategaonkar in Hindi would become Raste Gaonwasi ya Raste Gaonwale. Raste Gaonwale, depending on your personal choice. Again, first name basis make life easier. But you can see that even a common surname today created um, uses Panini's rules of 4000 BC, 400 BC, 6 to 4 BC, depending on what you like. So Panini employs this idea of zero in multiple ways. He says zero is pertaining to linguistic or grammatical description of different forms. Zero that is employed for grammatical operations, and zero is also used for sutra arguments. Amongst a few examples in English, there are three times becomes thrice. The double E, the three double E of three is disappears, and you get ICE as a replacement. So three times becomes thrice. In that sense, it is Lopa and early rudiments of Panini's compacting. Once, twice, and thrice are probably the only three examples that I can easily recollect where this kind of compacting is done. While in Sanskrit, it is routine. Lopa, therefore, is a form of null. Then there is second one. There are if you go and listen to recitation of some of these classics, or even in classical music, if you recite, you will see that there are long stretches of sound which have no words from a dictionary. They are just pure sounds for the pleasure of sound without any meaning. That meaninglessness of music, even vocal music, for example, uses it very heavily. That wordlessness gives you a very high degree of precision of form of verbalization of null. But what you're pronouncing is not an idea, not a thought, not a concept. It is just a nullness presented in a manner which keeps our senses attached to that sound. That's a phenomenal null on its own right. Um, there are other interesting problems that come up. So, for example, if you look at a 21st century book and ask what is the theory of knowledge, it says the knowledge can be acquired through sense perception, reason, emotions, faith, imagination, intuition, memory, and language. There are the 8 ways in which you can get knowledge. But in second century AD, Vaisheshika is written by I forget the name. Anyway, Vaisheshika says that the knowledge can only be obtained by 6 ways: perception, inference, analogy, derivation from circumstances, non-perception or negative cognitive proof, and verbal testimony of a reliable person. Pratyaksha, Anumana, Upamana, Arthprapti, Anuplabdhi, and Shabda. It Out of these, 1, 2, 3, and 6 are included in the Nyaya system. So Nyaya and Vaisheshika go together. In the 1, 2, 3, and 3 and 6 come from Nyaya system also. Vaisheshika explicitly says that emotion is not a way of getting knowledge. Faith is not a way of getting knowledge. Imagination is not a way of getting knowledge, and intuition is not a way of getting knowledge. On the other hand, artha, artha prapti and anuplabdhi both are valid ways of getting knowledge. This itself has its roots in the way Indian thought develops compared to the way European thought develops, but that is a story for some other time. Because Indian thought develops when people are still living a rather simple life, and early imaginative ideas essentially go by comparison. So we have inductive logic, and I'll come to that a little later. Well, European thought develops in a perfectly urban environment, so their perception is different. And I'll come to that a little later because it has some serious consequences on understanding zero. Zero in science, as understood in India, is also has a lot of null. So Vaisheshika is written in as a textbook of science in 200 BC. It's completely secular in the sense that it does not invoke God, it does not invoke inferences for anybody, it doesn't talk about prayers or anything. In fact, it explicitly goes on to say that causality is essential for everything to happen. Whatever you see happening has a cause behind it. And that very idea of cause, which is the basis of all scientific thought, actually is first expressed in Vaisheshika. It's a completely secular explanation about how the universe works and does not invoke God. There are several problems that there are several aspects that come up in that formulation, and let me just show you straight away the formulation itself. So the I think Kannada. I'm sorry, Kannada writes the Vaisheshika book. And he says matter and material have six aspects. There is Dravya, the material, and that Panch Mahabhut that you hear about comes over here. And then there are activities, Kala and Dika, which is time. Life's forces are Mana and Atma. They probably distinguish living and non-being, saying the living have Atma. And then they realize the animal and plant differences. So they come up with this idea of Mana, which is there in animals, while this is there in all life forms. And then there are gunas and colors and so on. I can't go into the details of it, but Vaisheshika is a book through which you can explain qualitatively almost anything that you see happening around you. There is a question about Babylonian use of zero, but that I will come to at the end of the thing. Babylonians essentially used it for simple arithmetic. If I buy 5 cows and sell 5 cows, I essentially have no cows left, kind of a thing. Okay. Uh, so moving further, non-existence in Vaisheshika itself is a very fascinating thing. So he classifies non-existence of four ways. He says prior non-existence, something just didn't exist. Then he says there is posterior non-existence, something that is destroyed and ceases to exist. Then he says there is reciprocal non-being or mutual exclusion. If A exists, then B doesn't exist. If an object is black, it is not white. If an object is, if there is dark, there is no light. So reciprocal non-being and absolute non-existence. Thing that could never have existed and will never exist, kind of thing. And all these non-existence, or the idea that non-existent entities are real, is there in Vaisheshika. And it's a book of science. It is not a book of religion. Okay, this is the null of science that comes in Vaisheshika, 2nd century BC. He also has a definition of Parmanu, which is very different from the definition of Parmanu we use today. We have just borrowed that word while not sticking to the definition that Vaisheshika itself gives. Vaisheshika says that, look, material cannot be indefinitely divisible. There should be a limit to dividability, because otherwise you can take a piece of stone, keep on breaking it until you have enough material to make a mountain, and that makes no sense. So the idea of using absurdity as an idea of proof itself also is there in Vaisheshika. And so Parmanu, therefore, is the ultimate individual limit of what it is. It is far from the modern definition. So there is no idea of atom, there is no idea of periodic table, there is no idea that today we associate with atom. Atom, he says, is the for the Padartha, that is the smallest entity. That is his definition. It is shapeless point object with no manifested properties and so on. But that is also, in that sense, a null. That is the limit of what can exist. Mathematics is something that Indians loved, and that is why Indians get the credit for zero, is largely for mathematics. And that because fundamentally, Indians made mathematics a language rather than a tool. And this is non-trivial. Indians use mathematics as a language, like any other language. Sanskrit is a highly precisely defined language. So they could easily come up with another language called mathematics, where the rules were very defined. The grammar is well defined, the structure is well defined, the sentences are well defined. And it was a language, and it was a language in which the heavens could be described very well. Indian mathematics, early Indian mathematics, Bhaskara and all, is only used for astronomy. It is not used in real world. Because heavens were the perfection, and these language of mathematics could be used for that perfection to determine planetary movement, to determine sunrise, sunset, to so many astronomical entities. Within this work, one can see his early ideas of Boolean logic. I already told you Pingala gave that. Differential algebra, which comes from the Kerala school of mathematics, and set theory ideas are also originally found there. Algebraic logic, which eventually the Arabs would go on to explore in great detail and pass it on to the Europeans in 15th, 16th century, essentially has its roots in some of the early work in Kerala school and so on. So let us see how this came about. Why does India get credit? Brahmagupta is the first one to sit and do a systematic job. So he says in this language of mathematics, Brahmagupta in 628 AD says the first one was essentially the first one to worry about how do I handle zero in my language of mathematics. Okay. And so he enhanced the importance of defining zero in an equation. And zero receives its due recognition because of Brahmagupta's work. And India gets credit for scientific zero thanks to Brahmagupta's work. So even though they had not invented it in the sense that arithmetic zero was being used earlier, they understood it, explained it, and used it in the algebraic sense of the word. And that is where the world of algebra was enriched so much by zero. So, for example, he writes down that in Bij Ganita, if you say x plus 0 or 0 plus x, essentially you get x. You get x. If you subtract 0, you essentially end up with the same x. And if it is x that you are subtracting from 0, you get minus x. If you multiply with 0, you get 0. If you divide by 0, Brahmagupta actually originally defines it as saying that 0 upon 0 is 1. Because it's a language, you can use any grammar you want. Later on, when mathematics is merged with physical applications, and I'll show that example, then things change. But otherwise, a perfectly logical system. It is not a mistake. It is just a language in which you define the grammar particularly. But he says exponentiation, x raised to 0 is 0 times is equal to 1 and so on, except when x equal to 0 itself. So he goes methodically through understanding 0, and he solves many equations for where x equal to 0 comes in. So he writes an equation, says what happens when x is equal to 0. Just aside, for those of you who are more mathematically minded, those who don't like mathematics much can skip this particular slide. But the best illustration is in set theory, where a set with 0 as an element is not the same as null set. And that is when the idea that 0 as an entity really strikes you. Originally, like I said, 0 upon 0 was defined as 1, and the entire algebra was done with that. Today's 0 factorial is 1 and so on. However, when people started using mathematics to represent physical world, they came across this very peculiar situation where there were two quantities, A and B. Again, if you're physics minded, then distance upon time, which gives you velocity. And instantaneous velocity comes when you get distance to be very, very small and time to be very, very small. Now, you don't know which one is approaching 0 faster. So that is when the original definition of 0 by 0 is changed to saying that 0 upon 0 is indeterminate in general, and you need special rules to determine the value of a function which is both are where both are going to 0. But in general, 0 upon 0 is undeterminate. But that is a change that comes later on when mathematics meets physics. Unfortunately, Indians did not use this knowledge to understand the physical world. They remained with purity of mathematics. And so the idea of instantaneous average speed, etc., that would eventually, for example, take Newton all the way to differential algebra and the whole Principia and all that, did not happen in India. We kept that knowledge in its purity. Indians also did not solve functions like fx equal to 0. When the entire equation goes to 0, they did not solve. They solved equations for fx where x is equal to 0. And that is because the very roots of Indian mathematics are different. But that is a story for some other time. So those zeros have contributed, so the zeros that India has are 0 of null, 0 of the great creator, 0 of meditation, 0 of grammar, 0 of mantras or music, zeros of Atma and Mana, 0 of Anu, and of course 0 of Bijganit. 0, of course, is Shunya becomes Sifar in Arabic and eventually becomes 0 in Europe. So the name itself goes from here. Then there is modern 0. Modern 0 in 20th century actually represents null. So in physical sciences, it is null. If two forces are equally balanced, we say the net force is 0. This balance of forces is related to 0, and it's used in a variety of concepts: acidity, basicity, just equilateral force also, and balance of forces and signals. In digital electronics, very low voltage is called 0. But there are actually three basic zeros in science, which are genuine zeros in the mathematical sense of the word. So, for example, mass of the photon, the carrier of light, is 0 in absolute sense. The change in the charge carried by a neutrino, another particle in physics, is 0. And the third grade 0 is the fact that when you cool something, you can go to a temperature of 0, but there is no such thing as negative temperatures. These are the only three absolute zeros in mathematics. Everything else are relative zeros. There is no such thing as perfect vacuum, for example. And artificial zeros are essentially either scale balancing or whatever you want to. In astronomy, 0 is used for singularity and infinite mass with 0 volume. The object moving with speed of light has 0 mass and so on. But those are peculiarities of 0 in mathematics. 0 of 21st century is the 20th century of computers. Well, not 20th century, 21st century. The computer science uses zero in a multiple ways. In digital hardware, the circuits are two-stage. The lower voltage stage is called zero, and the higher voltage stage is called one. And that zero becomes the first. And therefore, when you look at registers in computers, etc., the first register is called zero. It doesn't begin with the European idea of one, but begins with the Indian idea of zero. So, first register has value zero, simply because it gives you an additional convenience. On the other hand, leading zeros make no sense in arithmetics. So number 0235 is simply 235. But in computer, suddenly that zero makes sense. So you can have a password which says 0235 and it would be perfectly valid. Zero, suddenly, that makes no sense in the mathematical sense of the word, actually makes sense in the computer science sense of the word. So zero simultaneously loses its value and its ability to represent null, and comes up with a completely new perception of what zero can be. Zero becomes the first number, and zero also loses its value and its preciousness as representing null. So there are four. Philosophy has great creator. Grammar has this lopa and anuplabdhi. Mathematics has numbers, a number representing zero. Science has balance of forces, and computers, of course, have their own intrinsic electronics. And these zeros are not unconnected. So if you look at zeros of various kinds and ask how they are related to other zeros of the kind, you will find that you can make a network map of it. The religion zero all are together. The grammatical zeros come here, metaphysical zeros, abstract zeros, zeros of physical sciences, and zeros of music get connected in a very peculiar mesh of zeros. And that is, and that web is entirely Indian creation, because a lot of these aspects were not understood in the West for a variety of reasons. Then zero and cultural response. I don't know how much time I have left. I have 15 minutes left. Once humans start reaching level of complexity of thinking, they worry about who they are. So all cultures believe in some form or the other that there is a great God. The speculation then extends to beginning of the universe. Had the universe existed forever? Was it created, and how, and so on? And Indians like the idea of a creator who created the universe. The great God created the universe through order, or as Narsee Sukta would have it. And that brought forward the idea of what was before creation. And that is when the idea of null first strikes the very thinking process. So there was neither being nor not being, there was neither darkness, and so on. Europeans, on the other hand, stayed with the idea of the great supervisor of the world. And that one pervaded everything, and there was nothing where there was none. One. There wasn't one, and therefore zero made no sense. So the church explicitly forbade studies of zero. These differences and divergences between Europeans and Indians. Indians incorporated null as a real entity. The god was formless and could only be reached through sacrificial fires. There's also assimilated ancestor worships, who, of course, ancestors cannot be seen or touched or felt or experienced in any real way. But ancestor worship becomes a very integral part of religious practices. This was not true of Europeans, to whom life without one was unimaginable. One pervaded everything, and therefore one was the smallest number and smallest entity to them. Null or zero made them uncomfortable. There are interesting quotes. This is from Herman Weil in 1920. He says Occidental mathematics has followed a course which seems to have originated in India and was transmitted with additions to us by the Arabs. And in it, the concept of the numbers appears logically prior to the concept of geometry. Algebra comes before geometry, which is strictly not true, because geometry comes in the form of shape of Vedis for gods, Havans, etc. And there is a lot of geometry and algebra mixture that comes up. On the other hand, Richard Feynman says that there are two ways of doing physics. The Greek way, from first principles and axiom, and he calls what he calls the Babylonian way, which is relating one to another, which is essentially the inductive logic that Indians use. He says, I am a Babylonian. I have no preconceptions about the nature, what nature is like and what it ought to be doing. And I'll elaborate this a little. So Europeans found zero unnerving and would not accept it. While everything else was created, since everything else was created by one, that one pervaded everything. And it took them 13th century. India formulates a concept algebra of mathematics of zero in 6th century AD. It goes to Arabs by about 9th or 10th century AD. But Europeans still take till 13th century because the power of church is so much that they would not allow it. Eventually, the same Fibonacci, the famous Fibonacci of Fibonacci numbers, eventually forces at saying nothing doing, and he writes a book with zero in it, and he calls these numbers as Arabic numerals. That is when the Europeans actually first confront this idea of Indian algebra or Arabic algebra. It is only in 16th century that Europe church actually gives permission to use zero and numerical mathematics that follows from there. Set theory, it is only in set theory, like I gave you an example, that one really understands zero in a beautiful way. And therefore, then zero makes a very emphatic entry into science, because when you start measuring, you have these null points and other things. Primary difference between the logical use, therefore, is that Indians use deductive logic to understand nature. The principles are understood to understand behavior is axiomatic in Europe. And I'll just go give you an example of what is inductive and deductive logic. So, deductive logic of Europe says that universal premises, all humans are mortals. Particular premises that Mayank is a mortal, and therefore Mayank is a mortal. And it says that since all mortals die, Mayank will die. Inductive logic is another example to take that. It says that if there is fire on the hill, because there is smoke on the hill, and in the kitchen we see the smoke from fire, and therefore, but we do not see it in the case of a lake. We only see smoke when there is fire, and therefore there is fire on the hill. And to take the same fire example, in European context, you would say fire produces smoke, there is smoke on the hill, so there is fire on the hill. The same death example, Indians would handle it by saying that all humans are mortal because death is inevitable. Like my relative who died, unlike the tree that never dies or a mountain that never dies. Hence, we all will die, and therefore I will die. So there is an induction. I've seen something, and this looks similar to that, and therefore this is the truth. In Europe, it says there is an axiom that these are the statements of validity, and within that context, you analyze the universe. Deductive logic, as Bertrand Russell says, never produced anything interesting, whereas inductive logic goes a long way in creating new ideas. Comparison and limitations of comparison are actually a very fascinating subject. So, inductive and deductive logic, I'm going to skip this slide simply because of lack of time. But to give you an example, Paul Dirac, Nobel laureate, was a lover of deductive logic. He says it is more important to have beauty in one's equation than to have them agree with experiments. He says my equations are smarter than me because they are the rules now of deductive logic that he has derived. But those equations can throw more insight into various things than what I can understand. On the other hand, Richard Feynman, who loved inductive thinking, simply says that worship the phenomenon and not the explanation. I do not tell nature what to do. Nature tells me what is to do. A very great idea, a great deal of more truth can become known than can be proven. And in that, there is a shadow, of course, of Godel and stuff like that. So the general comment is rational and the intuitive were not divorced in India as they were in the West, and hence disparate logics could develop in India. Relatively open-minded Indians were permitted the inventions of zeros, whereas the Greeks and the Europeans denied themselves this great invention. The West adopted zero functionally and for its utility, essentially for mathematics, without having internalized the philosophical significance, we still find repugnant. That idea of nihilism is not there. And that awkwardness continues to today. For example, black holes should really have been called the null points of the universe, but they are called singularities because philosophically Europeans still struggle with the idea of nullness. Similarly, they also struggle with the ideas of infinities because Greek thinking explicitly forbids infinities. The bottom line is science prides itself in being cultural, independent, and absolute, but it is not. Cultural sensitivities make a lot of difference in the way we have insights. While rationality and experimental confirmation may be the final only arbiters in validating an intuition on the work of nature, one's perspective can be significant, very significantly, depending on one's cultural background. It is therefore important to be original and creative in thinking rather than accept cultural ethos of another culture. Uniqueness produces unique perspectives. So, for example, if you, just to conclude my last slide, if you are an Indian, you would ask, how can something as simple as zero be so complex? Well, if you're an European, you would ask, how can an entity that represents nothing can have an identity? Thank you very
Thank you so much, Mayank, for a wonderful talk. We really enjoyed delving deep into the concept of zero. Um, for the Q&A session, I think there were two questions in the chat box, one of
much. Okay.
which you did answer.
Yeah.
Uh, there's one by Naveen Bohra, in case you missed that. Izafa is a Persian or Urdu. In Persian or Urdu is somewhat similar concept of compressing sentences.
Cipher actually means zero. But
Oh,
I mean, words have different meanings in different contexts.
okay.
So lopo, for example, is disappearance. It is also used in so many different contexts. So words are used in a variety of contexts. And Urdu is an Indian language anyway.
Okay. Okay.
Its
Fine.
origins are in Lucknow, in Uttar Pradesh.
Okay. Okay. I hope that answers Naveen's question. Um, Rajneesh Mehta says when zero was utilized in multiplication and by which geography?
By which?
By which geography was zero
Uh,
utilized in multiplication?
so zero is used by Brahmagupta, like I said, in defining multiplication operations.
Okay.
And he uses zero, the oval zero that we use. So by that time, oval zero is very common because they know that dot itself can be confusing. They know leaving it empty makes no sense.
Mm-hmm.
And somehow they visualize something not having anything and circling it around to show that there is nothing is probably how the symbol of zero came in.
Okay. Okay.
And in order to make it distinguished from the O in English language, the zero is
Mm-hmm.
an oval while O is a sphere.
Noted. Okay. Hope that.
Um, there's a question about who wrote zero in Gwalior. Well, I mean, the king
Yeah.
there wanted to tell people that they have to pay so much of duty or zakat for going to a
Mm.
particular place. So it was marked in the stones there. So the local king at that time must have wrote it down. Exact author, we don't know.
Okay. Okay. Fine. So I think with that question, we come to an end of the talk. Would just like to read out the appreciation that has come in. Rajneesh Mehta says very interesting and mesmerizing talk. Sonali Chatterjee says very interesting and thought-provoking
Thank you very
talk.
much.
Thank you.
Thank you.
And Meera Desai says very interesting, even for someone who's math challenged like her.
Um,
And
Thank you. Thank you very much.
there's a question by Chaitali says, who named it zero? Any origin of the word?
So that comes from Pingala, 3rd century BC. He actually used Shunya to represent null. That is
Okay.
okay. So Pingala is credited to be somewhere between 2nd and 3rd century BC, but there are others who have claimed that Pingala actually is a brother of Panini, in which case he goes to 4th century BC. You see, India had this great golden period of intellectual creativity starting from about 500 BC till about 200 AD.
Uh-huh.
Buddha comes in at that time, Mahavir comes in at that time, whole bunch of Vaisheshika is written at that time. The great 6 books of Indian knowledge are all
Mhm.
written at that time. In that creative period, a whole bunch of ideas were created in India. And the great 6 books, Vaisheshika and Nyaya Vaisheshika and the other 6 set of books, Yoga and its corresponding Mimansa and Vedanga and stuff like that. Those 6 books all get created at that time. It is at that time that there is a massive creation. Yes, Nagarjuna also uses the concept of zero. Somebody just pointed out that Nagarjuna uses that concept very well. So it is there in Jain philosophy also. So this
Yeah.
idea of null is not in fact only a um, Hindu idea, if you want to be that And one
Mm-hmm.
should not be technical. It's an idea that belonged to the entire culture of that time, whether they were Buddhist, and the Buddhist philosophy also uses this idea. The very idea of nirvana is an idea of null. So
Oh,
it's an idea that pervaded the society, not a specific religious practice.
okay. Shweta has asked, do Chinese also accept the concept of zero? Did it travel through India or on its own?
No, it goes. So the Buddhists take a lot of Indian knowledge to China, and it
Mm-hmm.
travels with that. Till then, so China has very sketchy memory of Indian work. So, for
Mm-hmm.
example, they try to claim the Panchasiddhantika as their own. They define four and don't really quite fully follow it up the way Vaisheshika does. And
Mm-hmm.
therefore, we know it is not Chinese in origin. They get also the idea of nakshatras, which is also partial and incomplete. So, we know it's partially derived knowledge. Zero and that algebra also goes there. And those who are interested in transmission of zero out of India should read Al-Biruni India, 10th century AD. Al-Biruni is sent by the Arabs to study this culture called India. And he
Okay.
comes and studies India. And that book is now available in English. It's a phenomenal book. That man's intellect and ability to understand and write down Indian thought is phenomenal. At the end, of course, at the end of each verse, he has to say, but the Allah is the greatest and all that. But he actually says that these people of India know so much and so beautifully. It's a
Uh-huh.
pity that they have become so xenophobic that eventually it will lead to their downfall. And sure enough, in 200 years, that xenophobia kills us. But Al-Biruni actually documents how much of Indian knowledge has gone out
Mm.
around 1080. So Al-Biruni actually comes to India, stays for 10, 20, 20, 30 years, documents everything, and then takes it back home.
Okay.
And that book that he has written about India is now available in English. The original translation is available. And you
Okay.
can see how much we knew and how much we lost because we became closed and xenophobic at that time.
Sure.
One
Raman,
more question.
Somaya asked, is Shunyavad of Nagarjuna related to concept of zero?
Yes, 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 yes. It is, yes, it is some sense that philosophical zeros that I talked about in 2 and 3 is what is gets connected everywhere.
Okay. And Adil has asked, what was zero called in the Sumerian and Babylonian period?
At least I don't know because what we have is their multiplication tables and their addition tables and all that. I don't
Ach-
think their linguistic structures have survived. At least I really do not know. So we
Oh,
knew they knew zero because there are multiplication tables and there are addition tables and there is a trading, accounting and stuff like that. But how they spoke, I don't know.
okay. Prasanna has asked, do we find the zero in inscriptions? What is the sign for zero in the inscription?
So in the inscription in Gwalior, in the inscription in Cambodia, in a text written in Sanskrit, the zero is represented as a dot. In the 8th century, 700 something, there is a temple in Gwalior where zero
Hmm.
is represented in the modern zero in the form of an O. So the earliest inscription zero is in Cambodia, um, representing a dot, as representing zero as a dot. It says the tax you have to pay 605 whatever currency in that unit, and that zero 605 6, there is a dot and there is a 5.
Okay.
In Gwalior, it says you have to pay some whatever 700 something with a zero in between. There the zero is O. So somewhere between 4th and 7th century, we have this transition from dot zero to
Mhm.
circular zero.
Okay. Okay. So hope that answers Prasanna's question. And with this question, we come to an end to today's talk. Thank you once again, Mayank ji, for accepting our invitation and for such a valuable presentation that you've done today on the Khaki platform. We hope to have you again give a talk in near future.
Sure, sure.
Uh, yeah, thank you so much and have a good evening to everybody. And hope you join us
Thank
for
you.
our next events. Take care, please. Thank
Sure.
you.
Thank you. Thank you very much.